So in this section of videos, I'll be talking about the AI. This is the first AI that I made, and it is the totem pole one. It's the simplest of all of them. It doesn't require a state machine, and it's very simple, just like that. There you go, so you kind of get a feeling for the AI. It works by shooting out a raycast, which we can see if we go into the scene here. Obviously, this isn't as long the ones that it's actually shooting out are going off for absolutely miles. It works by, quite simply, if it hits the player, it will move, but first it will shoot. This requires the player to have to think about how it's going to defeat this AI. The way to correctly defeat it is to simply go onto either make the totem pole go onto the top of one, shoot from the middle platform, and then jump down, which means that it will move up into the bullets. I designed this AI because I wanted something that was almost like a puzzle in the game, and I'd thought about a few of the games that I'd done, and nothing had really touched on this idea of having to like not solve a puzzle as such, but having something like this where you have to bait the enemy into actually going into your bullets. It's an idea I really liked, and I think if I was going to redo it, I'd like to polish the code a little bit, which I'm now going to get into. It's a very, very rough way of doing it, and I had to rush this one a little bit because I really wanted to get onto the stuff with the state machines and bits and pieces like this. So how does that actually work? As I was saying, it shoots out two raycasts. It shoots out one to the left and it shoots out one to the right. These are arrays, so it hits everything to the left and it hits everything to the right. It then checks this array for the player. If it does equal the player, then it moves itself. It's exactly the same up here. It sends itself an integer as well. 0 is for left and 1 is for right. This here, this is the debug ray. This was so that I could make sure I was actually shooting in the correct direction, because before it was just not working at all, and it looked an absolute state, and it kept on hitting itself and it was getting confused. And that was actually one of the things that was fixed by the array, but it was also fixed by me correctly setting where the raycast should be. So when it moves itself, it does this. It gets the integer and it then sets it, and then if it's not moving, then it fires a bullet, and then it sets moving to true. Also, yes, so it does all of this. Sorry, I completely lost my train of thought there. Yes, it goes and it fires like this. So it fires the bullet, and it instantiates a bullet from its own position with the same rotation, and then gets the component of the bullet and works out the damage, which is damage, and it then gets the component of the bullet and it looks at the player, which is this too. Oh, sorry. So if we go onto enemy bullet, you can see here that if this 3 equals 0, it goes to the left, and if this equals 1, it goes to the right. This is where it actually moves itself, just here. So this is the way which I made it set up. So if the starting point equals 0, it moves to level 1. If the starting point is 1, then it does a random range, which basically sets it to either 1 or 0 with this bit of code. So if the random range is equal to or less than 50, it's 0, else the midpoint is 2. Midpoint is where it's going to move to. So for example, if we look at a level, we consider that to be 0, that to be 1, and that to be 2. So if it's on 2, the only place it can go is 1. If it's 1, it can go to 1, 2, or 0, which is where the random range comes in. And if it's 0, it can only go to 1 again. This is how you have to bait the enemy into your bullets, and this was very, very needed in my code. After all of this is done, it sets moving to false, and it ends the method. Overall, this AI was really simplistic, and it was more just to show off an idea than it was to actually put in my game. I'd always planned to come back to it and really try and fix it properly, because there was so many problems with it, especially with trying to get it to move to the correct position. while people were playtesting it, they really picked up on this, and they said it was the most clunky of the things. And to compensate for this, I gave it a huge damage. It does 12 damage to the player if you get hit by one of the bullets. And while this made it a bit of a more formidable enemy to come across, it also felt really lazy from me, and I really wish I'd put more thought into it myself. The next AI that I made was the heart. The heart is a weird one for me because I didn't really like it, but while playtesting, people said it was really fun, it was the hardest enemy to come across, and it was the only one people were really being killed by. And I found that a bit weird to me because I thought it was quite simplistic and boring. But I hadn't really playtested that much. I'd let other people playtest it so that I didn't get favorite AI, so I didn't spend too much time on them. Obviously, I still playtested to check for bugs and things, but I let other people have a bigger playtime with the AIs because I wanted their opinion on how I could change it. So here, as soon as it's awake, so as soon as the script is active, it does this. This is very simple. All it does is it's finding the player, which we've tagged with player, as we can see here on new Piscal 0. The tag is player. This is important. A lot of my scripts actually run off this fact. It then gets a float called position X. That is simply the player's position X, which is just the float, which is this thing. It then gets the Y, which is the player's Y, and then it sets a random X and a random Y between these positions, and the target position is a new vector. It also sets the health. The weird thing about the heart, or its quirk, if you will, was the fact that it could heal itself back up to 10 health. This is done with a state machine, which is just this very simple piece of code. All this does is that if it's that if the state is move, it updates the move component, and if it's healing, it updates the heal component. And it switches states here. I did it this way because it emulates the way real AI is done in companies and in AAA games and things like that. And I wanted to have some feel of professionalism to at least two of my AIs, which is why the Grunt and the Heart both have state machines. They're also very useful because it means that I can have updates running from this script and sorry, have these being updates even though they're not actually updates because they're being called from the state machine. This allows it to be updated every frame, giving a really nice feel. So I'll start off with the movement. The movement is very simple. All it does is vector2, current position is the current position of the heart, which is transformed opposition. If the current position is the same to target position, then this happens. And what this is basically doing is creating a new vector2 called target position, which will then be the new position to move towards. I did it this way because it allowed me to have a lot of control over the actual position of the heart and all of that without having to write too much. It works absolutely perfectly because the heart can go through platforms, which means that if the vector2 was set inside a platform, the heart can still reach it, meaning that there's absolutely no problems with the code there. This is all random to a certain degree. The randomness comes from the fact that it will chase the player. So the position X of it will always go to the position X plus or minus the width of the screen. The Y will do the same, plus or minus the width of the height of the screen. So to go through this properly, we'll have to just have a little look at the heart. So the heart level is this one. So if we just place it there, we might, no, the heart spawn is on there. There we go. And that isn't spawning a heart. Okay, sorry, give me 2 seconds. I'm just going to have to generate in one of the levels but I can't force which one it's going to be, obviously. So, right, hopefully we get lucky. I should have deleted all of them. Sorry, this is one of the problems found. There we go. Here are the hearts. So as we can see, all the hearts chase us. So now they're going over there. We run over here, and very slowly they will all come over here. They have no locking onto the player, as we can see from the randomness. So all they're doing is they're finding a vector 2 somewhere within the player's vicinity, and they're moving to it. You may notice that they never go below the character, and this is thanks to the on trigger enter here. What this does is it looks for the ground, and if the ground is if it does hit the ground, its target position is then the player's position x plus 0.6, which resets the hearts to about here of the player. This means that they could just like sort of go up, and then they then are next to the player, and it scares them a little bit, but it also gives the player a chance to be able to kill them. I did this because it was really frustrating for the players and for me when they were going under the ground and you couldn't shoot them and they would just stay under there, so you couldn't progress as quickly as if they were always visible. This bit here is simply just how I'm doing the health. So if it's shot, it will then just lose 5 health, and if it goes down to as low as 5 health, then it switches states to heal. Heal was its quirk. So if it's healing, it cannot move. It stops moving and it just stays there. This gives the player a chance to finally finish off the thing, off the heart. As we can see here. So healing equals true. It then heals up. Health equals health plus 5, meaning it goes back up to 10, and then healing is false. It will then reset this, and then it will start moving again if it gets up to 10 health. We can see this. There we go, the heart. So if we shoot it a few times, there you go, we can see it stopped for a second. That wasn't amazing, and it exploded. The exploding is the next part of this. That was quite different. It meant that the player had a chance of healing up without the item Healy. And for this, all I did was quite simply, for x equals 0, while x is less than 10, x is added onto once this is complete. It instantiates something which I called a mini heart. Now, a mini heart simply adds 1 health to the character each one that's picked up. So as you saw when the heart exploded, all these little mini hearts came out of it. This allowed the player to almost play strategically when the hearts appeared, because if they focus one down at a time, all the health that they had lost can be healed back up with the heart that they had just killed. And I really like this mechanic because it allowed for risk-reward scenarios to really play out nicely. This was, as I was saying before, this was one of my peers' favourite AIs, and I think it really worked quite nicely. The only thing I wish I could add to it would be to add a little bit more of a threat to the player. But I didn't want to do the same thing I did with the totem pole and just add more damage to it. One of the things that was suggested to me was maybe have some of the hearts that explode once it dies turn black, and if you pick up a black heart, then you lose some health. And I did like this, but with the time constraints and everything else, it just seemed absolutely stupid to me to then try and add this in. The next bit of code, or the next AI, should I say, that I wrote, was the grunt. The grunt AI is probably my favorite because of how versatile it is, and as you can tell by all the green text, how long it took me to get it working. So what exactly is going on with the grunt? Well, first of all, let's load up the grunt level, which was level 1. Here you can see that we have 3 of the grunts, 1, 2, and 3. has to be set up in some sort of thing with the grunt on an object, but as long as they are on a platform, then they will instantly understand how big the platform is, and they will move to it, as we can demonstrate here. Just go into the scene. So you can see here the grunt's moving left and right. If we then shrink this, say here, the grunt will now only travel. That was weird. Okay, that must have been just it adjusting to it. There we go, and it won't go out the side of that. This, sorry, I misspoke there. If we shrink it now, because as it is when it starts, it won't move outside these constraints here. So we could watch that all day and that would never leave from here to here. Unfortunately, it could have been done inside an update, but I didn't think to do that for some reason, and now sort of think about it now, I don't know why I did. But either way, I didn't, which was really quite stupid of me, unfortunately, because that would have meant that I could have really played around with levels and we could have had shrinking and expanding platforms that these grunts would always try and look for. But yeah, this is how it's finding the length of it and also where to put itself. So x is the width, it's how long it is, and this is done under a start, so this is only run once. And then y, this is the get component for the y, this sets its height. Now this allows us to mean that no matter what the grunt is on, it will always set itself so it's perfectly on, so it doesn't even need to be, in theory, in the actual creation of the levels, it just needs to be touching the platform. It doesn't need to be anywhere near it. In theory, as long as the ground is set, it will find it and it will go there, and then it will patrol it. This then sends a target position for a new vector 3, which is the ground transform position.x, random range somewhere in between the length plus y. And here we can see we've set private floats for the length and the height, which means that they can be transferred throughout all of this script and they'll never be lost. So we need to look for the player first, right? The print high is just so I could see that it was working. It was just basically running as a check. In fact, this isn't even needed, so I'll just change that now. So float x is the transform position x plus random range between the minimum length and the maximum length. So that is points from here to here. It will then set a current position of vector 2 and all of this. If target position equals current position, it sets a new vector 2. This is the same, pretty much the same bit of code as I did with the high AI, just here. I really like this way of doing it, as well, for one, I knew how it works, and two, it runs really, really simply, and I'm quite a big fan of just simple code that works. I really hate things that have been built up to be like these amazing things, when in reality you could just accomplish it with 2 lines and it would work just as well. I understand that sometimes there's the need for complex code, but unless there's a true need for it, I don't think it would be worth my time writing it all out just for me to then the next day think, oh, I could have done that in 2 lines. I'd rather think about it and do it properly the first time. Although in this one, as we can see, I messed up quite a few times with all the green lines. So then it just moves towards the target position. So it moves from the current position to the target position, timed out at time 3. This was just a way of me simply doing the speed. I use timed out at time pretty much because that's the way that I was told to do it by the Unity scripting reference. Timed out at time is every second. So divide that by 3 and it just creates a random float. I couldn't tell you exactly what it was, but this is the speed that I set on at this point. Now here I needed to get the box glider. The box glider is the bit that goes around it, and we can see on here. We click on one of these, we can see the box glider. We needed to disable this to shoot out raycast so that it wouldn't hit itself and then be like, oh, this is what I'm hitting myself. So that wouldn't work. If I was going to do this again, I'd go back to this one for a second and I'd use the array system, which works so much better. But for this was working even though it was quite unreliable sometimes. So as we can see here, actually, oh no, yeah, I did try and influence it, but I ran out of time and I just needed to get it working. So yeah, it sends out the raycast, it sends one out to the right and one to the left. It then prints hitting this, which is just for the left one. This is just so I could test it to make sure it was hitting the player. And then it re-enables the box collider, so you can shoot it again, because obviously while it doesn't have a collider, you can't shoot it, which means you can't do any damage to it, which would be unfair. And then this is the if statement here. All this is saying is that if either the raycast to the right or to the left hits the player, it then changes the state of the grunt to found. So if we go into the state grunt, we can see here that once it's found, it will print found, and it will also update the method gruntai.found. So if we find that on here, it then shoots out another raycast to make sure it's still there, because if it's not still there, obviously you don't want to shoot it because, well, yeah, it's not there. It then finds if it's either left or it's right. If it's left, it will shoot to the left using the enemy bullet. So if we go on enemy bullet, grunt shoot, just here, we can see integer left or right. If it's 0, left is true. If it's 1, then right is true. And this again goes into here, and then we either transform to the right or to the left or to the right. I always get them mixed up because I missed the little minus sign. So yeah, if we go back on here, and then if neither of them hit the player, it will then switch the state back to looking, which will then keep on updating this. I didn't use the state shoot in the end because I completed it in 2, and while I could have used a third state and it might have seemed more correct to do so in a way, I decided to stick with 2 because it meant less confusion for me, because it was quite simple to think, okay, right, because it was pretty much an on and off switch. That's how we can think of it. We think of it as either looking or found instead of also having a shoot. I based my state machines off of my old code, which I did for Games Jam, and I really wish I'd done a little bit more research into them, because I feel like I've wasted some of the potential of a state machine, as while this may have made it easier for me, it also meant that I wasn't entirely sure what I was doing right up until the end when I got everything working, which is why I have so many things just greened out and just generally makes the code look a little bit uglier. I think that's one of the big things I would do if I was going to go back to this project, is go back and just clean it all up and make it look all pretty and get all the code all nicely sorted out, because even though that would have no effect on the game whatsoever, you could ship this and it would have no difference to something that had no green on it. It's just nice to know, for me personally, that my code is all clean and everything. Spoken about the enemy bullet. The enemy health damage was put onto the totem pole. Sorry, I completely forgot the name there for a second. And this was just a way of just storing a bit of information for it. So if awake, so its health is 30. If the health is ever less than 30 or equal to, if it's ever less than or equal to 0, it will destroy the totem pole. And then once you shoot it, if the other dot tag is bullet, so once it gets hit by a bullet, the health is taken away by 5. If we delete this and re-enable the generation, we can see this one, for example. Kind of have to try and do that, and we can kind of start to see how all of the bits of code work together. And I think the AI turned out really well in this. The research that I did into them, I really tried to take from the ideas of it, but I really hated the idea of having to look up the code for it. And this was a big thing in my project, because I didn't want to have to look up the code. And one of the main reasons for this is it's just not how I learn. If I'm going to be trying to learn for our project especially, I need to be able to do it myself. I need to think about it. I need to come up with the solution by myself, because if not, all I feel like I'm doing is just copying somebody else's work, and I can't take what they've done and then change it a little bit, because